Okay, I would like to give a video demonstration of how to model a simple pendulum, 1 degree of freedom in atoms. Okay, so you need to go to engineering classroom and go to MSc software, and under that you will see atoms, and also you need to go inside that atoms view folder, and then you click on atoms and you'll get this atoms main working window. So once you open this, please click the new model. We are creating a new geometry in it. So as you click it, you see that there's a menu opens, and you need to just write down the name of your model. So let's write pendulum. Gravity, it's showing that by default is negative y direction. There's the units. If you want, you can change it by clicking down this drop down menu, and then I also set the working directory. You can choose any working directory that you want. Okay, so now this is the place where we will create our model. So you see, just to give you an idea about the menu, so these are the solid geometries that we can build, and we are actually building a pendulum link with a solid sphere at the end. Also there is a pivot joint at the other end. So what we choose is, here is the link. Let's choose that. It's under solid. So click this link, and you see there's a menu. We choose it as a new part. We click that we need to define the length, width and depth, and you define the dimension based on the problem. It says 600 millimeter in length, 27.5 millimeter in depth, width is 20 millimeter and depth is 27.5 millimeter. And then what you need to do is you need to position it, and select 2 points. So you click it here as your starting point, and you see the link becomes visible, and you make it horizontal and set it in the other point to position it like horizontally. Then you need to add a sphere at the end. So before that, let me change the view to isometric so that you can get a 3D image of that model. And then I'll go back to the same solid geometry and click on sphere. But this time what we do is we will attach that sphere to the link. So instead of making a new part, we just say add to part. And then we define the radius 100 millimeter of that sphere. And then you press enter. And then you need to say where do you want to put it. So first click, we want to add with part 2, which was the link, and then position it. You see, you can actually position it at different point, and then as it goes to the end of the rod, a circle comes out. But actually what I want is to put it at the end. So I click it slightly to the right, and you'll see a sphere at the end, and the sphere diameter is 100 millimeter. So now let's rename the part. So it is by default name was chosen, I think it's part 2. So to rename it, if you right click on the link, and then you get this menu. From there you select rename, and then you just modify the last part. So pendulum is the whole model, and then I'm renaming the part 2, and I'm renaming it as pendulum as well. Okay, and then you say click OK. So it is now pendulum. Now we have to assign the mass, and as the problem says, it's a 15 kilogram sphere, and the mass is centered at the center of the sphere. So let's right click on the pendulum now, and then you see the part is now pendulum. You should go to modify to assign the mass property. You see the body is pendulum, category is mass property, and we want to define it by user definition. So we just select user input, and then you see the mass here, put 15, which is the kilogram unit, and all these inertias make them zeros, and also we need to say where is the center of mass. So you click in this field, center of mass marker, right click there, and then you need to select the location. If you go there and then if you say modify, then you'll be able to select the pendulum center of mass. You see pendulum center of mass location is, I'm putting 700, is because 600 millimeter is the length of the link and 100 millimeter for the radius of the sphere, so it's total 700 millimeter. 0, 0 is on the aligned with the x-axis, and you say OK. You'll get a warning that you changed the mass property, but that's fine. Just close it and say OK in that box as well. So we have now pendulum ready, but we haven't actually added the joint yet. So the joints, you'll get it under connectors, and here you see there is a joint called revolute joint, and we will click into that. That will allow it the pendulum to swing. And then in this menu, you just leave these two things as it is, and then pick the first body as the pendulum. So pick the first body as the pendulum. You see it's a name pendulum on the screen. You see pendulum. So click pendulum, and second body as ground. See ground. So click ground. Okay. And the location, see also it will direct you. You see that this message at the bottom here, not here, it will ask you what to do next. It says you select the location, where do you want to put it. So that revolute joint, we want to put it here, which is 0, 0, 0, so click there. So you see that the link and the joint immediately comes into place. So the next, once you create the joint, we have to find something that we want to measure. As I discussed in the class, that we want to measure the joint forces in global x and y direction as this pendulum rotates. So let's define that. What do you want to measure? So let's right click on the joint, which is here, and then joint pivot. See, there's a one joint. Oh, before that, okay, let's rename it. Okay, let's rename it as before. So joint, rename it as pivot. Okay, and now you apply some measure into it. So go to right click again, right click on the joint. You see joint pivot, and then you click measure, which is this, and then you see what you want to measure. You can measure force, torque, displacement, angular velocity, acceleration, all these. So what we want to measure is the force, and at the joint pivot, and let's name it force at x. Okay, so you need to select x component. Also make sure these two, pendulum marker 4 and create strip chart, is selected. Say apply. So you see there you'll get a menu or the graph that will show you how that pivot force changes with time. Also create another measure, force y, and select the y direction and then leave the other the same and click OK. So you get another pop-up menu or another graph for force x, pivot force x and pivot force y. Once you finish that, we have to set a reference, because reference is important to define where the angle, from where the angle will be measured. So let me go to this section, bodies, and then you'll see in construction there is a axis icon there. So that is to define a marker. So you click there, so you'll see marker add to ground and global XY, and what you set is this one as a 0, which is pendulum CM. This is your one location. So let's set this one as your ground or reference, See, you get an axis, so you get a marker there, so it will be measured from here. And what you can do is from edit, you can rename that marker as pendulum ground angle reference, ground angle reference. Okay. Now, how will the angle be measured? The angle will be measured from here, that is the reference. Let's define that. So if we go to design exploration this time, see design exploration, and then we have to set that we want to measure an angle. So click there, so under measure to define a new angle measure, and click to advance, and then you name it pendulum angle, PEND pendulum angle. In the first marker box, you right click, choose marker, then pick, and then select the end of the pendulum, which is marker 2, and then go to the mid marker, select, right click, mesh marker, pick, click marker 1, which is the revolute joint. So we are defining 3 points that will define the angle. So, and then the last marker is the ground, which is here. Again, right click, choose marker, then pick to give you the last marker that you selected. You see ground ref angle. That's what you need to click. No, it's not this one. I need to create pick. Okay, so you see, we need to choose the ground angle ref that we created in the previous like section. So it will be marker 2, which is at the end, at the right end, marker 1 at the left end, and angle ref is the reference point for the angle. So all that will create the reference point, or how to measure the angle from the horizontal position. Okay, so we have we get another angle and another plot that will show you how the angle changes. But next, what we have to do is we have to set the initial condition. So initial condition is given as 45 degree is the displacement, and velocity is 3 radian per second. So you click on the joint, pivot joint, and then right click on it, and then go to joint pivot, and then select modify. You see there's a section, there's a tab for initial condition. You click on that, you'll just define rotational displacement as 45 degrees and rotational velocity as 171.88. These two are the actually radian per second, degree per second, and both these two should be negative because our angle is chosen positive in the counterclockwise direction. So it is theta is negative, or displacement velocity is negative in the clockwise direction. So it's 45 displacement and 178.88, which is equivalent, degree in second, equivalent to 3 radian per second. So let's set OK and OK there. So we are pretty much at the end. We need to check if the model is ready. So you see there's a small eye in the corner of information. If you right click it, you'll see a tick mark that will verify your model. So you click that to verify it and say model verified successfully. You can close that, and then the next step is to do the simulation. So if you go to the simulation, which is this tab in there, and then click this small gear icon, it will give you the simulation control. We said that we want to run it for 5 seconds with say 100 steps, and then you just click the play button, it will show you that it's moving. You get all the plots, but you can change the total runtime or the steps by changing these two parameters. But now let's look at the result part. The post-processing, if you click on the graph, it will give you a graph that you want to plot. I usually prefer a plot like this. If you go to this small button, right click it and choose a plot pattern like this, 3 layout view. So my goal is to plot a simulation there and 2 corresponding plots in these 2 plots. So if you click it, you see it will be highlighted red. So I click that. What I want to plot is, you see there the measures are in here. We have 3 measures: pendulum angle, pivot force X and pivot force Y. What I want to plot is in this one how the pivot force X changes with pendulum angle, and this one how the pivot force Y changes with pendulum angle. And this one I want to show the simulation. So let's click on the top right one and then select pendulum angle and say add curve. Also select pivot force X and then say add curve. You'll see those 2 curves with the legend in it. And the next, in the bottom one, if you click it and say similarly, you choose add curve, pendulum angle, pivot force Y, add curve, you get pivot force Y with the pendulum angle. So if you want to load the simulation, just click this one, the larger window, right click it and then say load animation. And then you will see that your model is there. You need to make it a little short. So if you press Z, it will give you the option to zoom in and out. If you click and drag it down, you will get a smaller model. If you keep it holding the left mouse button and drag it up, you will get a bigger model. So I think this is fine for our window. And also you see this is important that you change the speed of the simulation, make it like regular speed, and then you can run it. And you see its pendulum started to swing, and at the same time you see at every point or every angular displacement what the force is and what the force in X and Y is. So you can stop it. Also what you can do is you can track the values. So what you should do is click on this gear button. That will, so what you should do is you click on these graphs and then click on this small plot tracking icon here and then go to 0. What you see is on this top, on this here, look at these 2 values, X and Y. What you see is at X equals to 0, that means time t equals to 0, Y is 140. You get Y 140 and the other one is 40, the other one is you get 45. So 140 minus 140 is the pivot force X and 45 is the angle, which was our initial displacement. So that is right. Also you can check the Y force is 140.36 at time t equals to 0 and theta equals to 45. So that validates our actual analytical calculation. So that's the end of the demonstration. If you want, you can play with the mass of the ball or sphere. Also you can play with the can add the mass of the link, and also you can change the initial condition to get a different response. Okay, so for now, that's all for now, and I will talk to you later in class. Thank you.